Okay, so now that we understand individual voting preferences, we can start thinking about voting systems and deciding whether one voting system is better than the other, or kind of like what are the problems associated with different voting systems, right? So before we get into more details and examples, let's just make sure we understand what do we mean by the term voting system. So voting system is basically any method that takes a collection of complete or transitive individual preference relations, or now that we know that these are equivalent to a collection of individual rankings, and produces a group ranking, right? So the idea is that we are going to take as inputs individual rankings, and we want to produce a ranking which is true for the group, right? Now, when there are only two options or alternatives that are available to the different voters, the most widely used voting system is majority rule, right? So how does the majority rule work? The idea is that we ask each of the voters among the two options, which of them prefer option one versus which of them prefer option two. And then we basically select as the group's preferred option as the one which receives the maximum number of votes. Remember that we are talking about individual voters who have complete preferences. So each of them have preferences about whether they prefer option one or option two, right? And so therefore count the number of people who say option one is the best, count the number of people who say option two is the best. If the number saying option one is the larger, then you kind of like have option one as the rank one, right? Now we are going to assume throughout that the number of voters is odd, so there cannot be any ties, right? So that you cannot have equal number of voters saying option one and equal number of voters saying option two is the best, right? So we just want to rule that out. So we are going to have the case where the number of voters is odd. It's not that hard to modify whatever we are saying for even, but for ease of exposition, we are just going around with the case that the number of voters is odd. So, question is, can we design a voting system based on majority rule when there are more than two alternatives? When there are only two alternatives, majority rule does a very good job. What happens if you have more than two alternatives? So here, a common approach is to first kind of like think about group preferences by applying majority rule to each of alternatives, and then turn the group preferences into a group ranking. So how does that work? Let's take a more specific example. So consider any pair of alternatives x and y, any options x and y. Count the number of individuals who prefer x over y and the number of individuals who prefer y over x, right? If the first number is greater, then we are going to say that x is preferred by the group over y, and we are going to denote this by x is preferred over y. Note that this is very similar to the notation that we have seen earlier, except for the fact that you no longer have the I that you had underneath the preferred sign. This is because now we are representing this to mean the group's preference rather than any individual's preferences, right? If the number of people who prefer y over x is higher than the number of people who prefer x over y, then we are going to say that y is preferred by the group over x. And we are going to denote this by this, right? And this is what we are going to do for any pair of alternatives. So with this, we can always do, right? Since we have odd number of voters, we cannot have ties, right? Because then we cannot have the same number of voters saying they like x over y and a number of voters saying y over x, right? So what that means is that for every distinct pair of alternatives, for any alternatives, any pairs that you can think of, we are going to have exactly one of either x is preferred over y or y is preferred over x, right? So what that means is that not only are individual preference relations complete, when we are applying majority voting in this manner, the group preference relation is also complete. The problem, however, arises from the fact that even though individual preferences may be transitive, group preferences may not be transitive, right? When we are doing this majority voting system, right? So let's take an example of that. So imagine that you have three individuals, 1, 2, and 3, and they are deciding to vote over three options or alternatives, which we are going to call A, B, and C, right? So you have got rankings of person one is that he prefers A over B and B over C, right? Person two, on the other hand, prefers B over C and C over A, and person three prefers C over A and A over B, right? So you have got three individuals. These are each of their individual ranking, right? Now, what we are going to do is we are going to follow the procedure that we discussed. We are going to do pair by pair kind of voting, and then we are going to see that what is the group preference that is going to emerge from this, right? So first, suppose that you decide to kind of like vote between A and B. So in that case, person one is going to vote for A over B. Person two is going to vote for B over A, and person three is going to vote for A over B. So if it was a matter of pairwise voting between A and B, then A is going to be preferred by the group over B. So we are going to list that here as A is preferred over B for the group. What about pairwise voting between B and C? Which will the group prefer? So person 1 is going to prefer B over C. Person 2 is also going to prefer B over C. Person C prefers C over B, but you have got two people favoring B over C and one person favoring C over B. So again, as a group, the group agrees that you should have B is preferred over C. What about C over A? So person 1 prefers A over C, but both person 2 and person 3 prefer C over A, right? So then as a group, C is preferred over A. So what we see is that we have under this pairwise majority voting system that A is preferred over B, B is preferred over C, and C is preferred over A. Now, this is a violation of transitivity for the group preference, right? Why? Because if transitivity actually held true, then you would have had that once you have A is preferred over B and B is preferred over C, then by transitivity, it should have been that A is preferred over C, right? So we do not have that. And thus we see that group preferences do not violate transitivity. Note that it is kind of like not the case that individual preferences are not satisfying transitivity, right? Here we can see that individual preferences are satisfying transitivity. So for example, we can see that from person 1's ranking, A is preferred over B and B is preferred over C. We see that A is preferred over C, right? So transitivity holds true. From person 2's ranking, we see that B is preferred over C, C is preferred over A, and B is preferred over A, right? So this is again transitivity holding true. Similarly, for person 3, C is preferred over A is preferred over B, and C is therefore preferred over B, right? So at the individual level, transitivity is not a problem. It's only when we aggregate to the group level by doing this pairwise majority voting system, then we run into trouble and that we have a violation of group preferences being transitive, right? Now, the problem is that this is not just kind of like a theoretical curiosity. By the way, this phenomena is known as the Condorcet paradox, named after a French philosopher who was one of the first few to kind of like study this sort of pathologies that may arise in majority voting system. So the reason why this is interesting is that it has actually got a lot of like implications for the common type of voting systems that is preferred, right? So one common type of voting system that is preferred, especially when you want to kind of like rank different alternatives or options, is that you first decide to select a group favorite, then you remove it from the set of available options. Then you think about among the remaining options, how do you decide on the group favorite, and then you proceed like that, right? So a natural method, for example, is the following, that you arrange all the alternatives in some order and then eliminate one by them using a simple majority rule. So how does that work? So first you compare the two alternatives by majority vote. Then you compare the winner of the first vote between alternatives 1 and 2. Whoever wins, you compare that to the third alternative. Then again, between the winner of the first vote and the third alternative, whoever wins, you take it to the next round and then you compare it to the fourth alternative and keep on going till the winner of the final comparison is considered the group favorite, right? So these are sort of like elimination tournaments where you have got basically the winners being facing off against other players and then the losers are basically eliminated, right? So just as an illustration, so imagine that you had four alternatives, A, B, C, D. So first you had A versus B, right? Where whoever was the winner of A versus B proceeds to the next round and the loser of A versus B is eliminated. Then the winner of A versus B and C kind of like faces off against each other. Whoever is the winner of A and B winner versus C, it goes to the next stage. The loser is eliminated. Again, the winner here faces off against alternative D, and finally, whoever wins is the overall group favorite, right? So this is a very common way of kind of like applying preference ranking to get hold of like whoever is the overall group favorite. Now, the problem with this is that the Condorcet paradox suggests that kind of like you have a type of issue, which is the strategic agenda setting problem. So let's understand what this problem is saying. So let's go back to our original example. So remember the original example had this ranking, right? Where we saw that A pairwise defeats B, B defeats C, and C defeats A, right? So now imagine that kind of like the individuals have to decide one particular outcome to select among this A, B, and C using the system that we just discussed here in this graph, right? So you do not have D, you just have like till this C, right? So now who is going to kind of like win very much depends on the procedure that is decided, right? So overall, everybody agrees on the procedure, which is that first there's going to be a majority vote between two alternatives, and then whoever among these two alternatives wins is going to face off against the third alternative, and whoever wins that is the group winner, right? The question is which of the first two alternatives will be voted on first and which one will be held till the final vote, right? Now, the choice of agenda is going to be very decisive for this outcome, right? So, for example, suppose you want C to win, what should you do? You should have actually A versus B fight first. Why? Because if you have a vote between A and B, right, we see from here that A would defeat B, right? But now if you have a vote between A and C, we know that C is going to win, right? So if you wanted C to win, you should have A versus B in the first round. Similarly, suppose you want B to win, who do you want to have a vote in the first round? You want to have a vote between C and A in the first round, right? Then C defeats A. And then if you have a vote between B and C, then B is going to win. And if you wanted A to win, what you should have is a vote between B and C in the first round, right? In that case, B is going to defeat C, and then A can defeat B whenever you have a vote between these, right? So depending on who you want to win, you are going to have push for a different order in which the votes are going to happen, right? So the overall winner is determined by how the votes are sequenced, right? So particularly remember that voter 3 kind of liked C the most. So if you give voter 3 the power to decide on the agenda, then he would have had A versus B first and then the winner against C, right? Whereas if you had the person won the agenda setter who wanted A to win, then she would have had, for example, B versus C first, and then have it off with the with A, right? So this is the sort of issue that is kind of like emerges, and so therefore the group favorite is pretty much determined by the individual who controls the agenda, right? So this is a major issue there, right? So one question is that can we not remedy this by changing the system so that even if you are eliminated once, in order to be considered the group winner, you have to not only defeat the one who is in front of you, but you have to also defeat the person, the alternative which was voted out earlier, right? However, as you can see, if you have preferences like the ones that we discussed during Condorcet paradox, there's always an alternative that can be reintroduced to defeat the current candidate for the group favorite, right? So in this case, there would never be an end to this process, and we'll keep on going forever, right? So for example, suppose we apply this to this process, right? Suppose first we had A versus B, so that B was eliminated, and then we had A versus C, so that C won, right? Now, if you bring back B, then B is going to defeat C, right? But then again, if you want to kind of again bring back alternatives which are eliminated, so you should bring back A, right? So then again, A can defeat B, but then again, you bring back C, so C can defeat A, and so we'll never have an end to this, right? So these are some of the issues that are kind of like problematic for using majority rule in a very widespread scenario. And hence, that is what pushes us to think for other alternative methods that can be used as voting system.